All right, class, this video is going to pick up where we left off with our last mixed practice review. Let's work through number 8. This begins our word problems. Find the value of two numbers if their sum is 12 and their difference is 4. So our first thing is to realize we got to have two variables. Why? Because we have two numbers. So if there's two unknown numbers that I'm searching for, I've got to have two variables, x to represent one and y to represent the other. And again, you could use any variables you want. I just use x and y. When we look at some of the math language, we see sum, and we know that's addition. Is, that's equals. Difference, that's subtraction. Is, that's equals again. So I need to start working through some equations. My first one, I'm going to deal with sum. Well, if I'm going to add the two numbers, that's x plus y, and when I add them, this problem says they equal 12. So that is the sum of two numbers, sum of x and y, and it equals 12. Well, these same two numbers, when I subtract them, that becomes x minus y, and that's what makes this a system. I'm dealing with the same two numbers, so I have to use the same two variables. So when I subtract y from x, I get 4. And there is my two equations. So now I see that I have opposite coefficients in front of y, so I'm going to eliminate y. Those will cancel when I add, and that becomes 2x equals 16. Divide both sides by 2 and get x equals 8. So one of the numbers is 8. So let's plug it back into one of these equations, and let's just say 8 plus y is equal to 12. Let's just use that first equation. I'm going to subtract 8 from both sides and get y is equal to 4. So the answer to this question is, what two numbers? 8 and 4. When I add 8 and 4, I get 12, and when I subtract them, I get a positive 4. We can go ahead and check our work here just to make sure. We can check it algebraically. We could also check this graphically. Let's just use that second equation. That's going to be 8 minus 4. Does that equal 4? Yes, it does. So I feel very good about both of these solutions. And again, you could take both of these equations, write them in the form of y equals mx plus b, graph, and when you do that, they're going to cross at a point 8 and 4. This is where they would cross. All right, so you could check that graphically as well. Let's continue on with our word problems here. So in this problem, these first two sentences are kind of just setting the context. All right, so I'm going to outline those and just read them. The state fair is a popular field trip destination. That does not help you mathematically. This year, the senior class at high school A and the senior class at high school B both planned trips there. Again, sets the context. It really doesn't help you a whole lot mathematically. The senior class at high school A rented and filled 8 vans and 4 buses with 240 students. High school B rented and filled 4 vans and 1 bus with 54 students. Every van had the same number of students in it as it did the buses. So all the buses had the same number regardless of the school. All the vans had the same number regardless of the school. So what's our question? Find the number of students in each van and in each bus. So why don't we do this? Let's say x equals number of students in a van. We'll just say in each van. And what does y equal? Number of students in each bus. All right, so that's going to help guide us on our solution. So the first thing we need is an equation. We have two unknowns, so I know that I'm going to need two equations. And let's look right there for our first one. Let's just go with the first data they gave us. So this will be 8 vans, all right, and 8 buses, all right, equals 240 students. So again, x is the number of students in each van. If I've got 8 vans, I need to know how many students are in there because it's going to help me add up to 240. And the same thing with each bus. Number 2, I need a second equation. The other high school filled up 4 vans, 1 bus with a total of 54 students. And now you can see I have a system of equations. I have 2 unknowns, 2 variables, and I need to solve accordingly. And I think the easiest way to solve this one is elimination, and I'm going to eliminate the x. And so let's come over here and write 2 new equations. We're going to have 8x plus 8y is equal to 240. And let's distribute the -2 throughout. So that's going to give me a -8x minus 2y is equal to a -108. I have opposite coefficients here. So now those are going to cancel when I add all of this. That'll give me a 6y is equal to, that's going to equal to 132. I'm going to divide everything by 6 and get y is equal to 22. So how many students were on each bus? 22. All right, so now I'm going to come up here and kind of do a next step. I need to know how many students were in each van. So pick one of the equations. Let's just do 4x plus 22. I'm going to substitute 22 in for y equals 54. Subtract 22 from both sides and get 4x equals 32. Divide everything by 4 and get x equals 8. There were 8 students on each van, 22 students on each bus. So if you were to solve this graphically, it would cross at 8 and 22. That's where it would cross. And let's go ahead way back over here and check our work. Let's use the top equation. 8 times 8 plus 8 times 22 is equal to 240. Does it? That's what I'm asking. Does it actually? Well, 8 times 8 is 64. 8 times 22 is 176. So yes, when you add the two of those together, it does in fact equal 240. So I have 8 students on each van and 22 students on each bus. All right, so there is one more word problem. Please pause this and try it for yourself. All right, so Brenda's school is selling tickets to a spring musical. On the first day of ticket sales, the school sold 3 senior citizen tickets and 9 child tickets for a total cost of $75. So we've got to assign our variables. X is going to be the cost of a senior ticket. And we'll say y equals the cost of a child's ticket. I think that's the easiest way to approach this one. So on the first day, they sold 3 senior citizen tickets. So here's our first equation. We need 2 equations. We have 2 unknowns. That's going to be 3x, and that's a plus sign, plus 9y. How much money? $75. We need equation number 2. The next day, the school took in $67 by selling 8 senior citizen tickets and 5 child tickets. Now I have a system. Now, when you look at this one, there's no great way to solve this one. I'm going to have to multiply both equations by something. And I think what I'm going to do is multiply the top equation by 8. I'm going to eliminate the x, that is. Multiply the bottom equation by a -3. Why the negative? Remember, you've got to have opposite coefficients with the variable you're going to eliminate. So this would be 24x plus 72y is equal to 600. And then I'm going to have negative 24x. See, there's the opposite coefficients that I was looking for. Let's see, minus 15y is equal to negative 201. I had to do that real quick. Now, I have the opposite coefficients, so I'm going to change colors. Those will cancel. And what's 72 minus 15? That is 57y, and that's going to give you a positive 399. Divide everything by 57 to isolate the y, and you get y is equal $7. What's the cost of a child's ticket? $7. Now, let's come over here and kind of a step number 3 and solve for the senior citizen ticket. I'm just going to take the top one. I'm going to go ahead and take the bottom one, actually. 8x plus 5 times 7 equals 67. All right, so that's going to be 8x plus 35 equals 67. Subtract 35 from both sides. You get 8x is equal to, what is that, 32. Divide both sides by 8, and you get x is equal to $4. So the cost of a senior ticket is $4. The cost of a child's ticket is $7. So if you wanted to graph this and check, it's going to cross, these two lines are going to cross at 4.7. And that's what's going to happen there. And you could check your work here algebraically and ask yourself, let's use the top one, 3 times 4 plus 9 times 7 does that equal 75? Well, that's going to be 12 plus 63. And yes, that does in fact equal 75. I feel very good about both of these solutions.